A uniformly distributed load, or UDL, is a constant load that is distributed across an element or member of a structure, such as a beam or a slab. UDLs are useful in analyzing how loads are directed and stresses are distributed along a structural member. Take for example this concrete bridge. The weight of the slab is supported by 3 concrete beams that run along the length of the bridge. Understanding how the load is distributed allows us to work out where and how many supports are needed under the beams to prevent it from buckling. A UDL is also called a line load and is similar in concept to the linear mass density. But instead of having a unit of mass per unit length, the unit for UDL is force per unit length. Let's take an example of this concrete slab. A uniform slab has the dimensions of height, width, and length. Let's assume that we want to know what the weight distribution along the length of the slab is. We can define the volume as a product of the cross-sectional area times the length, where the cross-sectional area is a product of the height and the width. This allows us to work out the weight as a function of the slab length. We know that the mass of the slab is determined by multiplying the density of the concrete with its volume. And so, mass can be written as density times the cross-sectional area times the slab length. Finally, the weight of the slab can be found by multiplying its mass with acceleration due to gravity. The product of the density, the cross-sectional area, and gravity inside the bracket is called the UDL of the slab and has a unit of newtons per meter. Let's look at an example. Suppose this slab has a width of 600 millimeters, a height of 200 millimeters, and a length of 9 meters, and the density of this concrete is 2,400 kilograms per meter cubed. First of all, what's the weight of this slab? And secondly, what's the UDL that it exerts along its length? First, we need to convert the units to the proper SI units. So the height changes from 200 millimeters to 0.2 meters, and the width changes from 600 millimeters to 0.6 meters. Taking the formula that we've just derived for weight, we can calculate its weight by multiplying the density with the cross-sectional area, which is the height times the width, then multiplying that with gravity, and then the length. This gives us 25,402 newtons, or 25.4 kilonewtons, where 1 kilonewton is equal to 1,000 newtons. The UDL is found by doing exactly the same calculation except that we leave out the length. So the UDL is density times area times gravity, and this gives us 2,822 newtons per meter, or 2.8 kilonewtons per meter. So if this slab was sitting on top of a beam that supports it, for example, then the slab will be exerting a UDL of 2.8 kilometers per meter along that beam. Another way of saying it is that the beam has a uniformly distributed load of 2.8 kilonewtons per meter acting along its length. Let's take a look at the structure from the side view. Here we have the beam at the bottom and the slab on top. A free body diagram showing the forces acting on the beam would look like this. Here the red arrows represent the downward forces from the slab onto the beam. The arrows are evenly spaced out and have the same lengths, indicating that forces are evenly distributed along the beam with the same magnitude of 2.5 kilonewtons per meter. So this represents a uniform load distribution on the beam, but there are often times where the load distribution is not so uniform. Let's now consider how the weight of the slab would be loaded if we now had 2 beams supporting it, like what's shown in the diagram here. The 2 supporting beams are located along the long edge of the slab. We know that the slab has a weight of 25.4 kilonewtons, and for one beam, that represents a UDL of 2.8 kilonewtons per meter. But what's the UDL on each beam when there are 2 beams? Well, it follows from symmetry that when there are 2 beams, then each beam would take up half the load of the slab. So each beam would take up half the load of 25.4 kilonewtons, or 12.7 kilonewtons each, and will experience a UDL of half of 2.8 kilonewtons per meter, or 1.4 kilonewtons per meter. This will be true if the 2 supporting beams are spaced symmetrically. In the next video, we will talk about what happens when the loads are not evenly distributed and look at the concept of tributary areas. In summary, a UDL, or uniformly distributed load, is a load of a mass that is uniformly distributed along one axis. Because it's a force that is distributed along one length, then it has a unit of newtons per meter.